All right, everybody, here we go. We're going to go through the answers. This same sheet is available on the website, and we're just going to go through this piece by piece, and I've taken the one that I already showed you with all the answers on it. I'm just going to narrate through it for you to answer some questions. So let's go to problem number one. Whenever you're doing a problem like number one, the very first thing that you're going to do is you're going to figure out how to substitute. So you'll notice I highlighted this because we're substituting that in the place of y. So instead of writing this, rewriting this as 2x plus 2y, we wrote it as 2x plus, and then we put this in for the y. Let me pick a different color that stands out a little bit there. We put this in for the y. So this right here became what's highlighted there. Once we have that, it's a case of solving by going through, distributing, rainbows, going through, solving a two-step equation. You get an x value. You get this x value right there. Once you have that x value, then you take that x value, x equals 2, and you go back up and you plop it right there. So instead of x, you plop in the 2, and then you figure out y. 2 minus 2 is 0. Great. And then you go back one more time, and now you take the 2 and the 0, and you stick them right back in here again. So we took the 2 and the 0, and we said, well, 2 times 2 plus 2 times 0 is that 4. Yep, 2 times 2 is 4. 4 plus 0 is 4. Boom, we're done. All right, same thing over here, except the difference is, in this case, since they both equal y, we set them up equal to each other. So here's the first one. Let me do this with a highlighter. Here's the first one we had, 2x plus 10. So there's the 2x plus 10. Here's the second one we had, 4x minus 8 and 4x minus 8. And we set it up and create a three-step equation. And then you go through and solve the three-step. All right, so look at that. Read through that as much as you need to read through it. I'm going to get rid of some of those highlights just so it's not quite so crowded with stuff. On the graphing problem, we go ahead and we pick out the parts. So there, right there, the 2x, that's going to be, or excuse me, the 2/3 x, that's the m, that's the slope. So we always know, and we brought this problem down here, so all the work you're going to see for this is down below. So we had the 2/3, that's the slope, plus 2, that's the y-intercept. So we figure out where's the 2, and then the 2 over 3, that was an up 2 over 3, up 2 over 3, would have gone up 2 and over 3 again. You can see it right there, up 2 over 3. For the second line, 2x minus 2, we said, hey, let's rewrite that, 2x plus negative 2. So our slope is 2 over 1. Our y-intercept is negative 2. So here's negative 2. In this case, the slope is 2 up 1 over 2 over 1. 2 over 1. And then the spot at which they cross, the spot where they meet, that is the solution. That's the number that makes both of them true. If we take that number and we stick it back in to both of these, and we did that right up here, here's our check, they both work out to be true. All right, on to the next one. So for this problem, your slope, it says find the slope of the line using A to B and using B to C. So our slope is always the up and over. Here it is again, right up here. We wrote it. Let me highlight it. You want to keep thinking about this. We wrote it right there. That should have caught your attention on the video. Now let me get rid of it so you can actually read it. Our slope is how much y changes compared to how much x changes. So the change in y, when we make that triangle, we're making when we make this first triangle a right triangle with A and B, it's 2 up, 4 over. When we make this triangle with B and C, also a right triangle, 3 up, 6 over. Both of those simplify to 1/2. So when you answer part B, what would you expect the ratio to be? Well, you'd expect it to be 1/2 because the ratio is the same all the way down the line. Now, if you wrote 1/2, but you wrote it because you get 5/10, you got 3.9 or 3.8 for that, depending on your explanation, because you had to also note, yes, I know it's going to be 1/2. I can prove it with the 5/10, but I know it's going to be 1/2 because everywhere on the line has to be the same. All right, here we go. This was a big discussion in class. So, 2 questions. Which tree grows the fastest? So we figured out the slope of this line, 2 to 4, which is 1/2, means 1/2 an inch per week. I'm using my highlighter as a pointer here. Catch it right there. 1/2 an inch per week. Here we said it's changing by 3 weeks and changing by 1 inch. That's 1/3 of an inch per week. And here we went to their equation, 2/3 W. That's 2/3 of an inch per week. So the 2/3 of an inch per week, that's our fastest growth. Which tree is tallest after 15 weeks? Well, we turned each of these into an equation. So the equation for the pear tree was 1/2 an inch times 15. Okay, so in each case, in every single case for this one, for B, we're using this equation. Height equals whatever they grow by, so growth times W plus where they started. All right, plus their starting height. Starting. Okay? So for the pear tree, 1/2 an inch growth times 15 weeks plus the 7 it started at grows to 14.5. For the lemon tree, the one that we've done all the work here in the darker blue, 1/3 of an inch a week times 15 weeks plus it started at 8. That's 5 plus 8, 13. And for the lime tree, 2/3 a week times 15 weeks. It started at 2. Starting height right there, 2. Gives us 10 plus 2 gives us 12. That makes this one, the pear tree, the one that had the greatest growth after 15 weeks, tallest after 15. All right, number 6. So on 6, we have to first identify what's going on. So how much B spins varies directly with how much A spins. So we know A controls B. A controls B. So we know that that makes A the independent, which on a graph would be the X. B is the dependent, which on a graph is the Y. Slope is always the change in the Y over the change in the X. The change in the dependent, let me write that also. It's the change in the dependent over the change in the independent. So the dependent changes by 4s. This had a change of 4 each time. This had a change of 3 each time. So our constant of variation, which is the same as a slope, is 4 to 3. The equation, what equation could you use to find the number of times B spins given the number of times A spins? So B is the answer. The B spins is the answer. So it's the answer is equal to, in this case, B is equal to the constant of variation times the A, 4/3 of A. All right, number 7. We're getting to the end here. So number 7, is that a function? Yes, this one is a function. Why is it a function? What's the explanation? Because no matter what x you put in, you are going to get the same y. So if you put in any x value, And really the best way to test these is to test them by using a positive and a negative of the same thing. So let's test for x equals 1. So y would be 1 squared plus 2 times 1 minus 4. So then you go through and you, let's calculate that out. So the 1 squared is 1, 1 times 1, plus 2 times 1 is 2. Take away 4, that's 3. Take away 4, that's all equal to negative 1. So we put that x in. Every time you put an x of 1 in, you're going to get negative 1. Doesn't matter. Doesn't matter. Every time x goes in, every x that is positive 1 is always going to give you a y of negative 1. You're always going to have 1, negative 1. That tells you that you do have a function. All right, number 8, not a function. This one, fail. In this case, fails the vertical line test. So when you look at that vertical line test, remember what that means is when you draw a vertical line through the graph of a function, that's a terrible vertical line. When you draw a vertical line through the graph of a function, if it touches in more than one place, you've got a problem. Here you've got x of 2. So when x is 2, y could be a little more than negative 1, like negative 0.75. And it can also be just about 3. So this is telling you you've got a point of 2, 3, and you've got a point of 2 and negative 0.75. Well, that's a problem. The same x is giving you 2 different y's. That's the fail. And finally, number 9, is that a function? You bet. Every x gives you a unique y. It doesn't matter that the 2 4s, that negative 2 gives you 4 and positive 2 gives you 4. That's okay. It's as long as the same x doesn't give you y for 2 different values. All right, on to number 10, finishing it out here. So on number 10, we have Jason graphed the line that ran through. Those are the days he worked out. The graph was a straight line. Notice I underlined straight line. And it passed through the origin. That's that 0, 0. So what does that tell us? Well, it tells us slope of the line 1/2. No, it does not. It tells us the slope of the line. Here's my slope of the line right over here. Slope of the line is actually 2/1, or 2. Is the y-intercept 3? No, the y-intercept's 0. Look at that. It went through the origin, 0, 0. Did Jason run 2 miles per day? Yes, he did. That's what the slope tells us. Remember, from part A, we said that wasn't true because the slope was 2. That tells us the per day amount. And after 5 days, he ran 10 miles. You bet. If it's 5 days at 2 miles a day, there are your 10 miles. All right. So there's your week 21 test. Review that a little bit. Get ready. Be successful on the next test.